Hello, Coach Holmes here, and today we're going to be talking about geometrical probability, or geometric probability. And what do we mean by that is that it's kind of like when you actually have a target. And I'll just draw, and here's an example of a target. You know, you want to be able to hit that bullseye right here, right? So really what geometric probability does, or tells us, is the probability or the chances of actually landing at a certain area. So like, what's the chances of landing on a bullseye or any other section of a target? That's geometric probability. It's just what are the chances of landing at a certain spot or a certain area. So today we're going to be talking about geometric probability. Now, what I want to do, of course, I want to figure out the definition of it. And of course, we just talked about it. It's the likelihood that a particular area of a figure is selected. Okay? The likelihood that a particular area of a figure is selected. So again, it's just the idea of what are the chances of landing at a certain area. Now, what should the answer always be between? Now, what do we mean by that? It's like, what are the chances? Like when it comes to chances, it always goes down between 0 to 1, which means 0 means never, while 1 means always. Okay? Like if there's a 0 chance, that means it's never going to happen. There's not an opportunity. Do not even bother trying. That's what 0 represents. 1 actually means always. It's always going to happen. It's always going to be the case. Always going to work out. So with the 1, now what we're talking about is 1 is the same thing as 100%. Okay? Now, if I were to look at 0.5, that's 50%. 0.75, 75%. So our answers is going to be based on percentage, okay? So that's what our answers are going to be on. Our answers is going to be on percentage. Like what is the percentages of landing in a certain target. So today we're going to be looking at, I want to look at this area right here. What are the chances of landing in this spot right here, the bullseye to be exact? Well, there's two things we got to do. We got to find the area of the shade over the area of the figure. And that will give us our percentage. Okay? So what we got to do, we got to find the area of the shade that we're looking at over the area of the figure. So for example, I know it's going to be pi r squared for the circle. So let me put it right here. Pi r squared is the area that I'm looking for. So I'm doing pi, or better yet, 3.14 times 5 squared, because that's the area of the shade. All right? Now the area of the whole circle is pi 3.14 times 10 squared. Now I can multiply all that out to get 78.5 over 314. Now if I divide those two out, If I divide them out, that gives me 0.25. So really, I got a 25% chance of landing on the bullseye here. Not too bad. Not too bad. Not a bad chance. Now, so let's say I want to do this right here. And I'm going to do both sides. So again, so we're going to remember it says the area of the shade over area of the figure, or pretty much the total, okay? The total area. So I can initially find the total area using length times width easily. So the length is 100, width is 50, and I just want to make sure that's going to give me 5,000. So the area of the whole figure is going to be about 5,000 centimeters squared. Okay? But I'm looking at the percentage, so I don't have to worry about measurements too much. But now I got to find the area of the circle. So that's pi r squared, which is 3.14 times 50 is my diameter, so I can divide that by 2 to get 25 squared. 3.14 times 25 squared will give me 1962.5. But here's the problem though. I'm not looking for the area of the circle. I'm looking around the circle, pretty much outside the circle, but inside the rectangle. So how can I go about doing this? Well, I just gotta figure out what's left. I know what the circle is. I just gotta figure out what's left. So what I can do is I can subtract 5,000 from 1962.5. And that gives me 3,037.5. Okay? So 3,037.5 over 5,000. So I divide it out, and I get 0.6075. Now, how do we know what the percentage is? Move the decimal twice. So I get 60.75%. So really, I am more likely to land on the shaded area for this rectangle than I am to land on the bullseye. More likely. All right. So what we got to be able to do is we got to be able to find the area of the shade, the area of the entire figure, divide those two out, and then move the decimal twice just so we can get our percentage. All right. So just remember that it is the shade over the total in order to find your percentage. Thank you and have a good day.